Having learned the basics of particle making, we can now apply this knowledge to something a little bit more complicated. In this tutorial, I wanted to cover the notion of getting a closest point to a mesh and how it can be useful in a particle plugin or really any other plugin which you might be writing. So, as the first step, let's create a spray particle system just like we did in the previous tutorial. And again, we're using spray just because it is so easy to manipulate. And as the second step, let's create a mesh. For my case, I will use a teapot mesh, and I will be careful to place it in an interesting spot, like in such a way that it will wrap around the particle system, but it can be really any other direction. The reason I'm placing it here is to make the effect of our plugin a little bit more dramatic. So I will select my particle system, and I will throw a lab force field modifier on top of it, just like we did before, and I will click the edit plugin button to start editing the plugin. What I want to do in this plugin is to get the position of my particle and find the closest position on my teapot to this particle. Then I want to subtract these two positions to get the vector which will determine the particle movement in such a way that the particle will always be attracted to the teapot. So as the first step, I will add a new input and I will call it my mesh input. I will set its type to polygon mesh 3 so that I can accept my teapot as one of the inputs, and I will select it into my input. As the next step, I will right click on it and I will add the transformation for the teapot, just so we can work in global world space coordinates instead of any local teapot coordinates. And my first node that I will create will be a triangle mesh from a polygon mesh node. So this will take my mesh, which is right now a polygon mesh, and it will make it a triangle mesh instead, because we can only use the GetClosestPoint function on triangle meshes and not polygon meshes. If I drag out my triangle mesh node, and if I look in the list of the outputs, you can see that there is a GetClosestPoint output. This output will create a node which will allow me to specify as one of the inputs the position inside the local object space of my teapot, and as a result it will produce a point on the teapot which is closest to this position. And in addition to that, it will produce some other useful outputs, such as the square distance to the point which I'm specifying and the closest triangle index on the teapot. So into the position, I need to wire in my particle position, but I cannot do this at the moment because this position is in world space and this is expecting a local object space. So this is the reason why I added this extra XForm input, and I will drag it out to get access to the inverse of the teapot's transform. I will then create a multiply node, which will be able to multiply the inverse transformation of the teapot. Inverse transformation of the teapot by the world space position of the particle, and I will pass along this multiplied value into the position of the GetClosestPoint node. And now I need to multiply the result of this GetClosestPoint input, which is still in the local teapot coordinates, by the world transformation of this teapot to get it into the world coordinates. So I will just copy and paste my multiply node, and this time I will multiply the actual transformation by the result of this function, and this will produce the world coordinates of my closest point. So the next step is I already have the subtract node, which subtracts some value from the position of my particle. Instead, I want to subtract from the closest point the position of my particle, so I will rewire the subtract node. And the output I will just multiply by the incoming my input value, and I no longer need this node to produce my output. And if I play back, what's happening right now is just there is too much force going on, but we can already see that the particles are kind of being produced and they are kind of moving around the teapot. The only problem is that the velocity is too high at the moment. So I will go into my spray first of all, and I will increase variation just so the particles are not all going in the same direction when they're created. I will set it to something like 10. And then I will also decrease the particle speed. I will set it to maybe like 2, or even a smaller value like 0.5, just so we don't get a whole lot of movement. And then I'll go into my lab force field and I will decrease the value of my input just so that we don't get particles that are moving this fast. So now once I play back, we can see that there is already something much more interesting, and that is particles leaving the spray, and they are just sort of moving all around the teapot. If I just get out and go into the perspective view, we can see this effect much better. So we have our teapot here, and we have particles just leaving and moving all around it. And that is really the desired effect I wanted to demonstrate in this tutorial. And it shows the benefit of using this GetClosestPoint function to get a point closest to any arbitrary polygon mesh. Here we have a 10-second preview of our particle plugin at work, and as you can see, all the particles are moving the teapot and producing the results that we wanted.